Hey guys, so today we are going to discuss about the question called as unique paths. So this is a Leetcode medium question. So let's start reading this. So there is a robot on an M into N grid. The robot is initially located at the top left corner. So the robot tries to move bottom right corner. So the robot can only move either down or right. So given two integers M into N, return the number of possible unique paths that the robot can take to reach the bottom right corner. So what they're trying to say is they'll be giving you two values m, it might be some value, it might be another might be n, it might be some other value. So there is a robot in an m into n grid, right? So which is at the top left corner. So here, which is at the top left corner, right? So it want to reach the bottom right corner, so we have to return the number of ways it can go to the bottom right corner. That's the requirement. For example, let's take, we have a grid which looks like this. Let's assume we have a grid. So now this is a robot, right? This might not look like a robot, but let's assume this is a robot, right? So this is the top right corner. So what we have to do is we have to find the number of ways that it can reach to this bottom right corner. So whenever you see the equation which contains, you have to find all the possible ways or the number of possible ways, like that. So the first thing which comes to our mind is recursion, right? So the first thing which comes to our mind is recursion, because in order to find all the possible ways, that's the best way to, you have to recur and just find all the possible ways. So in this case also, first approach which would come to our mind is recursion. So you just recur all the possible ways, you just backtrack and just find out. Whenever you reach to this cell, you can just increment some counter like that and then return that count, right? That would be one approach. For example, let's say we come from here to here, right? You come from here to here, you come from here to here, and you come down and you come down and you come down. This is one path. And because you cannot come from here to here, because the only valid moves are down and right. So you come back, you come back, you come back. So now here, from here you come to here, you go right. Again you can come from here to here, you go right. You come from here to here and you go right. Similarly, there are many paths like this, right? As many paths as you want, there are many paths. So what they're asking is you have to find all these unique paths and send those number of paths. That's a requirement. So as this is, you are trying to do the same thing again and again. For example, let's say you have come to this position, right? You have come to this position at the beginning. Let's say from here you have come to here, but later you come from here to here, right? So you are doing the same process again and doing the entire recursion again, second time. So that would take a lot of time, right? So in this situation, especially when you are trying to do the same thing again and again, the best way to optimize it is using DP, right? The best way to optimize it using DP. Dynamic programming is the best way in the situations. So let's use DP in this. Let's try to use DP and let's try to optimize this solution. So let's take the previous grid only. Let's take the previous matrix, which is of m is equal to 4 and n is equal to 4, which is 4 by 4 matrix, right? So let's take this grid, and as we know, the robot will be at top left corner, which would be at this position. It has to reach the bottom right corner, which would be at this position. So first things first, let's assume we are here, right? So in order to reach this cell from here, what are the number of ways? Think that it's just one, right? Because this is just the only path from here to here. You can just reach only one time, only one way. It is only one way. We might think like I can come down, I can come right, and I can go up, right? But this move is not valid. You can only go towards right or left. That's the two ways you can go. But as you can go up, so the only way is just one. So this is just one way to come to here. Similarly, to come to here, it's just one way. Similarly, to come to here is just one way. Again, similarly, to come from here to here is just one way, right? It's just one. Again, if it is one here, it is one here. So that actually means all the boundaries or all the edges, it's just one. I mean, not these edges, just the right and left, right and down edges. So now the actual thing starts. So how many ways are there to come to this position? Think that. So first thing, think, how can I come to this cell? Either I can come from this to here and from this to here, right? So If I can come from these two cells, and if I know the number of ways I can come to this cell, and if I know the number of ways I can come to this cell, then I can just sum up these two and add 2 here, right? That would be the number of ways to come to this cell. Did you get my point? I think you got it, right? So for example, let's say similarly, let's take how many ways are there to come to this cell. So to come to this cell, first of all, I can come from here to here, or I can come from here to here, right? So if I know the number of ways to come to this cell, and if I know the number of ways to come to this cell, then I can just sum up these two and just add 3, right? Similarly, to come to this cell, there are 2 ways, either coming from here to here or coming from here to here. And if I know the number of ways to come to this cell, and if I know the number of ways to come to this cell, then coming to this cell would be just the number of ways from here to here, right? Which would be 4. So again, I can come from here to here, and I can come from here to here. So this would be just summing up these 2, which would be 3. So similarly, so what you're trying to do is just taking the top cell and the left cell and summing the values and just replacing it here. So in this case it would be 6. So in this case it will be 10. So in this case it would be 4. This is 10 and this is 20. So each cell represents the number of ways we can come from this cell to this particular cell. So that actually means the value in this bottom right corner is the answer. That actually means from this cell to this cell, the number of ways is 20. So this is the answer. So basically the formula what we have found is, let's say the array name is dp. So dp of I comma j is nothing but dp of I minus 1 comma j plus dp of I comma j minus 1. So I minus 1 comma j is nothing but the top one, j minus I comma j minus 1 is nothing but the left one. So we're just taking the top and left values and adding them and placing it in the current cell. That's it. That's what we are going to do. This is the formula basically. So let's try to see how can we implement this using the code. Let's try to implement this using dynamic programming. So here we are having a method called as unique paths. So it's called as unique paths, and it passes us m and n, where m represents the number of rows and n represents the number of columns. So as required, we need a grid, right? So let's take a grid. So let's call it as dp, and it's of size m comma n, right? So as we have seen before, all the ways or to come from this robot to these edges, I mean to these boundaries, the number of ways is just 1, right? So let's try to place it 1. So for int I is equal to 0, I is less than n I plus plus. So now the number of ways to reach to dp of I 0 comma I would be just 1, right? Similarly for the column as well, for int I is equal to 0, I is less than m I plus plus. So the number of ways to reach I comma 0 would be just 1, right? I'm just placing 1 in these places, in this first row and first column. So now as we have started before, from the 1 comma 1 cell, for int I is equal to 1, I is less than m I plus plus, and for int j is equal to 1, j is less than n j plus plus. Now as we have seen before, the formula is taking the top and the left cell and adding them up. So dp of I comma j would be just dp of I minus 1 comma j plus dp of I comma j minus 1. So this would find the number of ways to this particular I comma j cell. So at the end I just have to return dp of m minus 1 comma n minus 1, which is the bottom right corner, which will be this cell. So this is pretty much the solution. So let's try to run this. Yeah, see, it worked. So let's try to use some extra test cases. Yeah, it worked. Let's try to submit this. Yeah, cool, it got succeeded. So this is how you find the number of paths to reach the bottom right corner from the top left corner. So this we have done using dynamic programming. This is like a bottom up approach. You can also do recursion and just optimize that by using some hash map like that, but I felt this is the best way to do, so I thought of explaining this solution. So you can even try those later after trying these. So if you like the video, please make sure you like and subscribe. Thank you.